Hey guys, we are going to finish up the last 5 questions of AP Classroom Quiz Review 1, and then we're going to do number 7 and number 8 of the AP workshop we did from the last unit. So watch these videos, take a look at your work, and check them and make sure you understand, and you can ask questions. You can email, or you can wait until I see you back in school. Alright, so let's look at number 16, because that's where we left off. The rate at which water leaks from a tank in gallons per hour. So whenever we're looking at gallons per hour, we know that we're in kind of like the velocity world. Because remember, we've got gallons, then we've got gallons per hour, and then you've got gallons per hour squared. Okay, because remember, when you are deriving, you are adding in the units on the denominator. If you integrate, it's when you're going up. Now, they say, which of the following is the best interpretation of R prime? So they want you to derive. So if they're asking you to do the derivative, you're looking for gallons per hour squared. So you go through and you read each one, and gallons per hour squared, gallons per hour is right here, option number D. Okay? Or letter D, for that matter. Alright, so let's move on to number 17. Number 17 says, let's get that back in focus, there we go. A particle moves along a straight line. The graph of the particle's velocity at the time t is shown. So we're looking at the derivative graph. And then it tells us a whole bunch of information about J, K, L, and M. But they want to know where the speed of the particle is decreasing. So basically where this thing is slowing down. So you're looking for signs that are different. Now, here, your velocity is positive. V is positive because it's at the top. Down here, your V is negative because it's down at the bottom. So up above the x-axis where velocity is positive, below the x-axis is where velocity is negative. Your acceleration is going to be the slope of the tangent line. So you've got a positive slope of the tangent line. So right here, positive for velocity and positive for acceleration. But right here, it's negative acceleration. So that's our first one, from J to K. So J to K is our first option. Well, there's only one option that has J to K, but we can keep going. So down here, velocity is negative. Our slope of our tangent line is negative, so they're the same sign. But over here, the slope of our tangent line is positive. So velocity is negative, acceleration is positive. So that is our second part, from L to M. Okay? That takes care of number 17. Now, number 18. Sadly, I don't have one of those cool calculators at home. Mine is not a TI-84 Plus, it's just a TI-84. So I can't really show this to you in the calculator, but I can tell you how you would solve it. So if you're looking for a particle moving along the line, so the velocity is given, what values of the speed increasing? Speed increasing. So you're looking where the velocity and acceleration have the same sign. So you want to graph them both. You want to graph V of t, and then you want to graph A of t, and you want to see where they have the same sign. Whether they're both positive or whether they're both negative, it doesn't matter. It turns out that they are both positive from here to here, 0.177 to 1.256, and they are both negative here. So your answer turns out to be E. Number 19. So number 19, they're asking us to use an approximation. So local linearity. Now remember, when you're doing local linearity, you need a point, which they give you, and the point is 317. You then need a slope. Well, the slope, when x equals 3, is given right here. G prime of 3 is equal to negative 1.2. So you have y minus 17 equals your slope times x minus 3. Change this into local linearity format. And then you want to plug in the 3.2. So f of 3.2 equals negative 1.2 times 3.2 minus 3 plus 17. Now, sadly, this isn't a calculator problem. So you're going to have to do a little work on this one. You'd have to do a little algebra. You have to do negative 1.2 times 0.2, and then you're going to have to add 17 to it. Takes a little extra steps, but they're not super bad numbers. All right, number 20. Number 20 says it's a calculator, although you don't actually need it. So they're giving you the function d of t, and its depth in feet of t hours, okay? And they want to know which of those represent the instantaneous rate of change. Well, instantaneous rate of change is derivative, and you want to do the derivative at 6, so your answer is B. Okay? So that finishes off AP Quiz Review 1. So now we're pulling up number 7 that we did in class. Okay, this is an AP workshop, so it started looking like this: AP Workshop Integration and Riemann Sums. We got through number 7. You had to do number 7 for homework one night, and we never did go over it. So we're going to go over it right now. So number 7 says, rocket A is positive velocity, and so they give you all of these points. And for part A, it says find the average acceleration of rocket A over the time interval 0 to 80. So think about it. If they've given you velocity, the derivative would be acceleration. And derivative is just slope of the tangent line. Now, because they're doing average acceleration, they want slope over the average amount of time. So you want the slope as time goes from 0 to 80. So for part A, your first point is 0.5. Your second point is 80.49. And you want to do the slope of that. Now remember, they don't give you a calculator. So since they don't give you a calculator, you could technically be done. But 49 minus 5 is 44. So you could have your 44 over 80. Now I do believe they ask you for the units. Indicate the units of measure. Now again, think about it. So you've got feet, then you have feet per second, and then you have feet per second squared. And since we've done what is essentially the derivative, we've gone down, so we're in feet per second squared. Okay? All right, part B says, using the correct units, explain the meaning of the integral from 10 to 70 of v of t. Okay, well, think about it. You're right here, and you're going to integrate, so you're going up. So you're going to end up with feet. Well, if you're ending up with feet, that's going to be the distance. So it's just going to be the distance the rocket has traveled from 10 to 70 seconds. Now, some things in feet. So you've got to tell them what kind of units you're using. You've got to tell them where you started, where you stopped. And so you need all those pieces when you're doing it. The distance the rocket traveled from 10 to 70 feet in second, or 10 to 70 seconds in feet. All right, the next thing says use a midpoint Riemann sum with 3 subintervals. Well, if I'm doing 3 subintervals, let me see if I can't get this here. Keep in mind you're going from 10 to 70. So I'm going from 10 to 30, 30 to 50, and then 50 to 70. Where my midpoint is 20, 40, and 60. So my change of x is equal to 20. So I want the y value of the 20, the 40, and the 60, and I want to multiply that by 20. So let's see, the 20 has a 22, the 40 has a 35, and the 60 has a 44 height. So my width of my rectangle is 20, the height of my rectangles are 22, 35, and 44. Now again, you don't have a calculator, so you can be done. Okay, this is an AP question where they don't require you to add all those things up and multiply, so don't waste your time. Now, again, if we have a calculator, it's fine, it's 2020, but you don't have to, okay? All right, part C. Part C says rocket B is launched upward with an acceleration, so they've now given you acceleration at time t equals seconds. The initial height of the rocket is 0 feet. The initial velocity is 2 feet per second. Well, so basically what they're telling you is that v of 0 is equal to 2. The velocity is 0. Initial velocity equals 2. And then which of the two rockets is traveling faster at 80 seconds? So we need to figure out the velocity. So if we've been given acceleration equals 3 over the square root of t plus 1, we need to integrate that. Because if you integrate acceleration, you get velocity. Okay, think back up here. Okay, you've been given velocity and you want to know distance in feet, so you want to integrate. Actually, sorry, you've been given acceleration. You want to integrate to get your feet per second velocity. Now, this is a u substitution problem. U is actually t plus 1, where u dt is equal to 1. So this would be 3 over the square root of u du. I can't take the integral of that with that u in the bottom or with that u as a radical. So I'm going to bring it to the top and change it to 1/2. So it'll be negative 1/2. Now, when I integrate that, I'm going to get 3u. If I add 1 to negative 1/2, I end up with 1/2, which means I then need to multiply by the flip of that, which is 2 over 1. So I end up with 6 square root of u plus c. Okay? So v of t is equal to 6, the square root of t plus 1, plus c. So now I can use this, bring it back down. 2 is equal to 6 times the square root of 0 plus 1 plus c. So 2 equals 6 plus c, and you get negative 4 equals c. So v of t is equal to 6, the square root of t plus 1, minus 4. Now, from there, they wanted us to know, well, what was going on at 80? Okay, well, what's the velocity at 80? Well, if I plug in 80 in there, that's the square root of 81, which is 9. So I end up with 50. Well, if we look back at our original up here, the original at 80 was 49. So we have rocket B, this is rocket B, is equal to 50, when rocket A was equal to 49. So rocket B is faster. Yay! Alright, now, if you have not worked out number 8, go ahead and pause the video and work through number 8. If you already have worked through number 8, then great, keep watching, and we will do number 8 together. Get rid of that paper. Alright, so number 8 says, a function f is defined on a closed interval from negative 5 to 4. The graph of f consists of 3 line segments. Let g be the function divided by g of x is equal to the integration of negative 3 to x of f of t dt. Now, what that's telling us right here is that this graph of the f is the graph of the derivative. Okay? It's the derivative graph. So remember, things are not as they seem. So we've got to keep that in mind. Now, they want us to find g of 3. Well, 3 is where the x is, so we want to plug it in where the x is. So, we are going to integrate from negative 3 to 3 of f of t dt. Well, integration is just finding the area under the curve. So we need to find from negative 3 to 3. So I need to find the area of this big triangle, and then I need to find the area of this little triangle, and I need to subtract them. So the area of this big triangle, so 1/2 base times height. Well, my base is 1, 2, 3, 4, 5, and my height is 1, 2, 3, 4. So that is going to give me a value of 10. Now this little triangle here is 1/2 1 times, it looks like 2. 1/2 1 times 2. Well, that means that it's 1 and it's negative. So this is going to be 10 minus 1, or 9. Okay? They didn't ask us for units. They didn't give us any units, so we really can't do anything with units there. Okay, so that's part A. Part B says, on what open interval is the graph of B both increasing and concave down? Well, f is the derivative. So, where f is greater than 0, the function is going to be increasing. Okay? Where f is decreasing, that will be where g is concave down. So we need to look where f is positive and decreasing. Well, it's positive and decreasing right here, and it's positive and decreasing right here. Your derivative is positive on the top, and it's decreasing in those two sections. So you're going to say from -5 to -3, and then again from 0 to 2. Okay? Now, you have a reason? Well, you just did, right there. Boop, boop. Because f is greater than 0, that's where the function is increasing, and f is decreasing, and that's where it's concave down. Okay? All right, part C. Move this up a little bit and down. Part C says, Part C says the function h is defined by that function, g of x over 5x. Find h prime of 3. So they're just asking you to find the derivative. Well, if two things are being divided and you have to find the derivative, that means you are doing the quotient rule. So, for part C, we say that h of x is equal to, what did it say it was? G of x over 5x. G of x over 5x. So the derivative is the bottom times the derivative of the top, minus the top times the derivative of the bottom over the bottom squared. Now, they wanted you to find h prime of 3. So that's 15 times g prime of 3 minus g of 3 times 5 over 15 squared. Now, you can't be done yet. You got to figure out what g prime of 3 is and what g of 3 is. Now, g prime of 3. Well, let's go here and look at part A. Alright, so g prime of 3. So, okay, just kidding. We have g of 3. G of 3 right here, whoops, right here, g of 3, we found right here, okay, because look at A, g of 3. So we found it to be 9. So we know that this one's going to be 9. Okay, so now we're going to find g prime of 3. So the derivative at 3, well, where is 3? So 1, 2, 3 is right here. So it's this line right here. We need to find the slope of that line. Well, let's think about it. This is down here at -2, and then we got to count up to here. So it was rise of 2, run of 1, and it's going in the negative direction. So the slope of that line is -2. So that is what's going to go in right there. So 15 times -2 minus 9 times 5 over 15 squared, which you can stop. They didn't give you a calculator. You do not need to figure out all the arithmetic. Okay? All right, and our last one is D. So the function p is defined by this right here. Find the slope of the line tangent to the graph where point P, where x is equal to -1. All right, so what we need to do is find the slope of the tangent line, which is the derivative. So, part D, if P of x is equal to f of, what was it, x squared minus x? Let's see. Yep. We got to find the derivative. Well, that's the chain rule. So that's the derivative of the outside times the derivative of the inside. And they want you to evaluate that at -1. So f prime of -1 squared is 1 minus a -1, so that'll be f of 2, or f prime of 2, times 2 times -1 minus 1, so that's -2 minus 1, or times -3. So f prime of 2, f prime of 2, well, let's take a look here. There's f prime of 2, well, there's 2, well, we already know that slope. That slope was -2, we just found it, so it's the exact same. So we're doing -2 times -3 equals 6. Okay? So that finishes out number 8. When we are in school next, I can pull up the scoring guide. We'll take a look at the scoring guide to see where all the points come from and how they score it. Because in a lot of places, they give you points for things, and I want to make sure you understand what those are. All right, have a great snow day. Bye.